Welcome to week 14. We're almost done. 1 week left of class. Well, this week and next week, and then a final. And so, yes, there is a final in here. The final will be available online. You might want to make sure you know some trivia about Monty Python. So I tend to have those kinds of questions in there. So next week we'll talk a little more about that. There is a discussion board this week. And this week's a little different. I know we're almost done, but I'm declaring this an amnesty week for one assignment. So, for this discussion board, I will put in a passing grade for one missing assignment that you tell me about. With this caveat, you have to tell me a story. You have to tell me a fake story, made-up story, to get a funny, why did I not turn this in? So, if you can make me laugh, you get a passing grade. If you make me laugh a lot, you might even get 100 on there or 100% on a missing grade. So that's your discussion board for week 14. So let's look at what we have to do this week. So click on assignments. Well, I had a student online say, I've had enough tests. So you know what? We don't even have a test this week. We eliminated the quiz. I know everybody is getting a lot of materials in other courses, so we just took it out. If you really want to take it, we can get to it. You do need to read this chapter this week, graphics and image processing, in order for this to make sense. And then we actually have 3 assignments in this case study. 7.2 and 7.1, the case study, are not graded. However, they help you set up for the other 2 assignments. So case study 7.1 will actually lead you through some of what we're looking at this week. So this week we're looking at doing some very elementary graphics. And one of the things that Python does not have a real good piece native is graphics. So we actually have to use some code that we import some libraries, and there's a whole different kinds of types and different models that you can use for code for this. So we're going to look at some pretty simple ones this week. So Python does allow you to coordinate and interact with them, and then we need to look at how those work. So I would encourage you to do, before you do anything else, and I'll just move it right now all the way up to here, that case study 7.1. So our first programming assignment, let's make sure it will launch. I had some weird Cengage issues last night, so hopefully it will pop back alive. So our first assignment, as it slowly goes here. So we're going to create a function called drawCircle. And we're going to use something called turtle. So turtle is one of the ways that we can draw some very simple objects is by using turtle. So we want to make a couple of functions in here. We delete what I already had there. So we're going to draw a circle. So how do we draw a circle? We need to remember some formulas. So some of this will be familiar. So we're going to create a circumference. So we're going to draw a main function that will draw a circle with the following parameters. So here's our main. X equals 50, y equals 75, and a radius equals 100. We're going to pass them, though, then into a function called drawCircle. And here we actually do something a little interesting. So not only am I calling this function, but notice I'm calling a function inside. So I'm actually calling that function turtle, which we've imported in. Oh, I may have grabbed that out of there already. So turtle we actually have to import in. So up at the very top, we need a couple of functions. So we need import math, simply because we're going to use pi. So that gives us our math functions. And this one's a little different because turtle is a function, so it's really laying out here beside here, and our program here inside of Cengage hides it from us. But normally we're going to have to import turtle and bring it in. So we don't have the file for turtle, we're importing it. So from the file turtle, import the function turtle. So turtle's one of the ways we can create graphics. So we know we have a function, and we've already given the name here called draw circle. So we can start defining that. So define draw circle, and in fact it even gives it to you here. There you go. And so draw circle is going to take in several different variables. So we know it's going to take in x, y, and a radius, and the function turtle. So T for turtle, we know we're going to take in x, y, and we need radius. Now, just to remember, even though we're using the same names here, x, y, and radius, I can't see that directly. It has to get sent through this function call for me to be able to see that inside of my function. So, because I imported turtle, it gives me some dot notation. So I have a couple of things that we can do, and we can create this then. So because I have t, I can sit here and go t dot, and it will allow me to have some functions. So I could do a t up, and in this case I'm not passing anything into it. And then I could do a go to. So in other words, I'm navigating to a specific point. So in this case, I've already said here's my x and here's my y. So those are my starting locations. And so what we're saying is here I want a radius of 100 units. I have a location that starts at x and y. And I need to figure out how I can draw some of that particular thing. So what I also know is here I'm going to draw this circle with a radius of 100. So I'm going to go to a spot on there. So I'm going to go x plus my radius to move it all the way to the right. And so I'm going to do x plus radius. And we can see what happens if we don't do that. And I'll show you here in just a second. And then our value for y. So we're going to a specific location. So how are we going to start moving? So we're going to start moving at 90 degrees. So in other words, to the right. All right. Now we need to get multiple units. So we need a loop of some kind, because when we want to create this point, it's a set of discrete points based around a particular area. So for count, and over here it says we're going to move in a given distance 120 times. So 360 degrees in a circle. Each time you're doing 3 degrees, so in other words, you're dividing it up into 3 little areas. So here's where we get a little tricky. So we know we're going to do 120 different units. So we have a loop that counts up 120 times. All right. So we've created a point on our circle where we're going to start. So here we created that point on our circle we're going to start. So we're going to move in a left direction 3 units. And then we need to calculate that next position. So here's where we have to use our formula. So 2 times pi times our radius. And we're going to divide that. Did I spell radius wrong? No. US. Divide that by 120. So in other words, we're again having that each time we're going 1 3-degree increment. All right. So the turtle graphics are a little weird to start with. So when I run them, I'll see what happens inside of Cengage. This might be interesting. Bad input online. What line did I have? Line 4. What did I do? Draw a circle. TXY radius. Oh, hey, you know what? Try it again. All right, there we go. S is not defined on line 11. Oh. 2, not S. Just to indicate that it's a... Let's try that one more time. Yay. And so now, over here, you can see where I started at. Okay, thanks for sharing. So we created a circle. Let's see if I can make this a little bigger here. All right, run. So we created a starting point, and it drew that then in a big circle. So let's say that we change that. Let's try changing that to 60. So this is one of those areas where you can experiment and see what can happen. So if I only do 60, then I drew half of my circle. So let's put that back to 120. Now we make our circle. Well, maybe we want to change that radius. So maybe we want to change that to 50. Well, I make my change in my code. And now I've made a circle that's got a radius from a center point of 50. So I can change its origin. So if I went in here and changed this to... So notice we've moved it up and to the left doing that. I could make a very small circle. So turtle graphics are not necessarily the greatest way to do things, but it shows you that grid that we're creating. So if I decide to do this at 0, 0, let's see where 0, 0 will land on our little bit of real estate here. So we could even then say, well, let's do it at negative 50. Let's see if that changes our x, y coordinates. And it looks like it does. So we can experiment to kind of learn a little more about how the turtle graphics, where it does. So it creates a grid on your screen, and then you can manipulate and put points anywhere in there. So notice when I did the tee up, if I eliminate that, watch what happens. So it went there, and it went from its origin, but it drew the whole time. Huh. And that's not necessarily what we wanted to do. So normally, or if I do this one, do the same thing, you can see what will happen. So it flew in all right. So it started at its origin and moved in there. So you can do some experimenting and see what would happen then on any of these. So we want to move it back to 50, I think it is. And y is 75. Radius is 100. Let's see if that's still right. So on here, we could change some of this if we wanted to. If we wanted to do each individual point, so 360, we're going to have to change our range to 360. And pi radius. So now it draws our circle, and it calculates every point. In fact, this, I screwed up somewhere. Oh, it's doing it by threes. So in this case, it's going to actually draw it 3 times then. Made a nice heavy line. So it's kind of hard to see in here. So in case, I would have to actually change that to 1. And now I could draw my circle. And so now, notice it's taking a lot longer to draw. Instead of plotting every 3 dots, it's plotting every single dot. And to your eyeball, you're not going to notice that difference. So when I get ready to grade this thing, so this time it's going to say, well, let me see what's happening. And so it's got a piece of code that actually recreates that internally and says, oh, I have a 0%. So to see if we can fix that, so let's take that to 120. So again, we're dividing it into 120 pieces instead of 360. All right, make sure that works. I didn't do anything really silly. And notice how much quicker it runs. And you don't see the difference because it's drawing little 3-degree arcs in there. And so, at least in this case, you're not going to see the difference in there. So let's see if it'll work now. So that would actually pass. But if you want to see the difference, so for example, instead of 120, we did, let's go 6. So 360 divided by 6 is how many degrees? 60, I hope. And we're going to divide this by 6. So now we're doing it in big giant arcs, just to show you what the difference would be. So what we're really doing to create a circle is we're making smaller and smaller little arcs. And so it's turning and doing each one of those. So you could make it, well, maybe I want to have an 8-sided object. We could do that. That would be 360 divided by 8 is 30 something. So you could change this because what we're doing is just coming around in little pieces. So 120, you don't see the 3s. So to your eye, it looks like you're doing and so if you really examine that or blew it up, you'd see that we're in little short arcs. All right. So that's actually 7-1, kind of getting you used to the idea of how we can do this. Well, if I do that in idle, so come back here, it will actually do the same thing. It pops up a little window for Turtle Graphics. Come back here. There we go. So very similar code. So again, we have to pull it in, and so I've got to have that library available. And we can change the graphics on this. Now, it should be a little smoother outside of, brings up another window every time. So once it runs, here we go around our loop. And here you can kind of see a little better because it's bigger, that those 3-degree arcs are what they look like. So if you don't like those and you think, well, that's not smooth enough for my purposes, we can change it. So we can say, all right, well, we're going to divide it into 360. So 360 times we're going to loop. We're going to move forward 1 unit. And now I can run it. And it's going to be very, very similar. If I draw this out here. But what you'll notice is, due to the limitations of the graphics, you're probably not going to see a lot of difference between 3 degrees and 1 degree, because it's still going to be kind of blocky. We don't have a really high resolution graphic on there. So you could cause this to repeat. So if I wanted to draw overlapping circles, I could then do this if I wanted to. I'm just going to copy that. So maybe I wanted to create some overlapping circles. So now instead of 150, I'll move this to 125, leaving the Y the same, and it's going to draw 2 circles. So that's one of the advantages to calling that function like we do, is it can repeat itself multiple times. So here we're drawing our first circle. And then we fly in the arrow again to another one, and now we're going to draw another circle. So we can start to create some really interesting effects then. So if I wanted to keep doing this, I could actually wrote a loop. So let's take a look at our program here. So I'm going to make it a little quicker. I'm going to go back to the 120s. So we're dividing it in thirds. And that becomes 120. So instead of changing this like this, so I could actually write this into a loop of some sort. So we could do a while loop or a for loop if you wanted to. So for, let's do like 10 of them. And we can certainly change that at any time. So now we need to scoot these in. And then we started with x equals 50. So I might move that up a little bit, and I might say x equals 50. Y equals 75. It's kind of center to the screen, not too horrible. But now I might say I want to move those up 25. 25 units. And maybe I'll change this slightly too. I'll go y plus 15. And so now we'll create a circle. Yeah, I did something weird. All right, hang on. Oh, hang on. Chunk. Hopefully if I get that all in the right spot. Run module. So now that should run one circle. Come in and do another circle, and we're going to go up and to the right just slightly. So again, clearly there's a couple of issues with the turtle graphics, and the biggest one is they're a lot. It's not very a fast way to draw objects out on the screen, but it's certainly, if you had time to build them. And we're obviously not limited to circles. We can draw all different kinds of functions with that, because what we're essentially doing is moving this cursor around and creating trace lines out on the screen. So there's our 10 circles changing in direction, going up, so they're overlapping. So you can end up with some really interesting artwork. And in fact, the next assignment that we're going to work on, we'll talk about what we can do with that. So that's 7.1. And again, experiment with it. That's part of the fun of this, is see what other things you can do. So can I send this arrow somewhere? What happens if I don't? So there's lots of details about turtle graphics. So if I just looked at turtle commands, you're going to see there is a lot of different things you can do. So here's one called a turtle star that you could create, and in fact we can do some colors, so you could see what that would look like. So there's moves, there's forwards, there's left, right, positions, whether you're actually drawing in different colors and different things. So it can be effective. The biggest issue for me, and probably for you if you try to create something with it, is it's a little bit on the slow side. So turtle graphics are one of the easiest way, though, to get that in there. So I'm going to close this out. So you should be able to complete that one pretty easily. 7.2 I want to look at really quickly. So 7.2 is not a graded assignment. So 7.2, you should have all the curve components in here. So we can actually just run this. So you can experiment again with some different things. So this one says we need a level. And then it should create a graphic in here for you. And why is it not running? Maybe it's not showing everything here. Hang on a second. Over here. Move over. So what this is doing is essentially creating. So notice here, it created a whole series of lines and did some colors and some other things. So I will actually send you the code for this one to work with, so that you have all of the correct code. It looks like it's all there, but so we're going to have a curve, and then we say, how do we do it using random colors? So it's just kind of an interesting program to look at. So I will make that available. And so different levels. So here I said I want 6. Yeah, come back into the right window. So it made it a little different approach, just because it. So if I said I wanted 60, it would give me a different response. So 60, it's just churning away, but it's so small you can't actually see the different pieces in there. So close that out, close this out. All right, I will I thought I had it where it would all peel in there. Let me give that to you. And you can assemble and play with that if you would like. For 7.2. And then you can just copy and paste that in. The only thing with copy and pasting that I've ran into that's really weird is making sure that your quote marks, if you paste in and out of something like Word, it wants to make the left and right quote marks, and that's not what you want to do. So there we have a copy of 7-2 to look at. So our only other assignment then is going to be 7-3. And so if I jump to 7-3, get out of my way here. So in this case, we're going to make a snowflake. And we're going to use it doing something called a fractal. So we're going to actually create a program that's going to create a fractal. So here we have some initial information. So initial angles are 0, negative 120, and 120 degrees. Initial size can be any size. If the level is 0, the turtle moves the given distance in the given direction. Otherwise, the function draws 4 fractal lines with 1/3 of the given distance, angles that produce the given effect, and the given level minus 1. All right. The function draw fractal is recursive, so we know we're going to have a function in there. And we're going to write a script that draws a Coke snowflake. So we start at 200 and 200. So its width and height, they're both 200, size 150, and we're going to use something, we're going to call it level 4. So if I come back up here, you can see the different levels. So what this should look like, let me see if I can find it real quick. When you run, well, let's do a level 4. Did I grab the wrong one? I did. Hang on. I have too many files open. All right. So in this case, we're creating that snowflake. So here's one. We've preset the coordinates. And so really what it's doing is creating small little pieces and repeating that over and over and over again. So that's what we're going to challenge you to create. A lot of this material's in the book. But they are not fast, especially on this machine, to create. So depending on the speed of your machine, this may go a lot faster. So our poor lab computers some of them are a little old and, well, ancient. But what it's doing then is creating this design based on the parameters that you set. So we'll let it finish its drawing. So give you a couple starting points. We always have this constructor on the bottom. So if we have a main, we know what we're going to do. And so this says we're going to create a function called draw Coke fractal, and we're passing in a set of coordinates. So we're passing in height or width, height, size, and a level. So we can change any of those. So if I go in and change it in the code over here, that you can't see yet. I'm going to make that twice as big, so I'm going to go 400 by 400, and I'm going to make the size 300. Let's see what happens when I run it. And so now it starts that drawing, and so now it should be a little bigger, but you can see how it creates the structure here. And again, this will take 20 minutes for it to draw out. So we will work on this one on Thursday, figuring out how we can create something. And these are really kind of neat to do. You'll see that we're going to create a fairly large snowflake. And you can start to see the pattern of how it rotates 0, 100, and 120 degrees negative, so it moves around. All right, so I'm going to leave you with that. Remember that. Where did I put him? Hang on. So there isn't a test this week. No test. I gave you a sample for 7.2. 7.1 you do need to turn in. We went through that. 7.3 we will work on in class on Thursday. And then there is a discussion board. So if you are missing any assignments, that discussion board would be a great way to get at least one of those back. So the better the story, the higher the substitution grade. So tell me stories. Tell me amusing stories. Don't tell me horror tales. All right.